So we're going to explore a little bit more with ratios and proportion. So let's look at the first scenario. The ratio of tomatoes to red apples is 2 to 5. If there are 20 tomatoes, how many red apples are there? So let's look again. We have a ratio of tomatoes to red apples. So for every 2 tomatoes, you have how many red apples? 5. Awesome. So if you have 20 tomatoes, how many red apples are there? What is it that you need to look at? What is it you need to do? All right, let's see. So we just stated that information. We have to know we can equate 2 ratios. So the first ratio would have been 2 to 5. Then the next ratio would have been 20 to an unknown, because we're trying to figure that out. Since we have the tomato ratio, the tomato proportion, what is the relation between 2 and 20? You know it, man. So 20 is 10 times 2, right? So that means I would have multiplied 2 by 10, and that would give me 20. Therefore, that relation must also exist between the 5 red apples in the first ratio and the red apples in the second ratio. So let's multiply the 5 by 10, giving you 50. So that means for the first ratio, remember it's 2 to 5. You multiply both portions by 10, you would get 20 to 50. That means when you have 20 tomatoes, you will end up with 50 red apples. All right. So, and this would keep the ratio the same, because if I were to simplify 20 to 50 by dividing by 10 clearly, we'd get 2 to 5. Awesome work. All right, let us understand ratio a little bit more. So we have another scenario. A classroom had 35 glue sticks. If the ratio of glue sticks to glue bottles is 7 to 2, how many glue bottles are there in the class? So let us review what we have. We know that there are 35 glue sticks. We know that there is a ratio between glue sticks and glue bottles. What is the ratio? So you have glue sticks to glue bottles. So that means for every 7 glue stick, you have 2 glue bottles. Now, you know, you could do this an old-fashioned way. You could just go and write 7, 7, 7, 7 until you reach 35. But we're not going to do that. We can figure out relationships. So we'll ask, how many sets of 7 can we get from the 35 glue sticks? And if you said 5, great job. So if you divide 35 by 7, it would give you 5. That means the relation between the 7 and the 35 is 5. So I can apply that relation now to my other portion. So if it's 2, for every 7 I have 2, that means if I have 35, I would have multiplied it by 5 to get 35. 2 multiplied by 5 gives me 10. So that means when I have 35 glue sticks, I have 10 glue bottles. Let me just go back through that, because I'm thinking I said a lot of things right there. So first, you know you have 35 glue sticks. There's a ratio with glue sticks and glue bottles. So remember now, you know how much glue sticks you have 35, and you need to figure out how many glue bottles you have. The simplest ratio you have is 7 to 2. I can now scale up my ratio. To get 7 to 35, I would multiply by 5, giving me 35. If I multiplied my 7 by 5, I also have to apply that relation to my other portion of the ratio. So 2 multiplied by 5 gives me 10. Therefore, my new ratio becomes 35 to 10. There you can see it. All right, excellent. Now, find the actual distance. So we are here now on a little map. And as you can see, it's not much distance on the map. We have a lighthouse and a dock. Yes, the scale can come in a fractional representation. So don't think you're just going to get whole numbers. So here we have a scale of ½ inch equal 3 miles. So what does that mean? For every ½ inch on your map, it will give you 3 miles on actual land. All right. So using the ratio and the scale given, what is the actual distance from the lighthouse from the lighthouse to the dock if it measures 4 inches on the map. So what does the ½ inch to 3 miles really mean? Which we just said. So you know this. So it means for every ½ inch on the map, it represents 3 miles of actual distance on land. Let us look at how we can work through this. So as you can see, the 4 inches in. So from lighthouse to dock on the map, it's 4 inches. You are now applying the scale. As I said, there's always what you'd call it. You can always reason it out. It's going to take you longer. And in life, we want to be more efficient. Because you know the efficient worker, the efficient person, achieves a little bit more. So we don't want to draw out 4 inches and say, okay, ½ inch, 3 miles plus another 3 miles. You could do it that way, but that's not how we're going to do it today. So the proportion exists. ½ inch, 3 miles, 4 inch, how many miles? That's what we're trying to figure out. We can cross multiply, and then you'll realize that you have half multiplied by that x give us half x, 4 multiplied by 3 gives us 12 there, right? Now, we're really trying to find x. So what do? We will solve, or what we call make x the subject of the formula. Now, to get x by itself, you multiply by 2, but you must do it to both sides of your equation. So we will end up with x is equal to 24. So that means if you have 4 inches on the map, it will actually represent 24 miles in actual distance. Now, there's another way we could look at it. So here we go. 4 divided by half. Why you divide it by half? You want to see how many groups of halves you can get from 4. And you guys, you should, you can reason it out, I always say to my students, so if you have 4, every one you have 2 halves, right? So 4 wholes will give you 8 halves. So of course, that means you would have applied 8 to get to 4 from the initial ratio of ½ to 3 miles. So if you just multiply again, 3 times 8 gives us 24 miles. All right? So there are 2 ways I gave you that you can look at it, and you'll figure it out. Now, reason it out and you can tell if your answer is right or wrong. If ½ inch give you 3 miles, clearly the answer that you're going to get must be more than 3 miles as well. And ½ inch is less than 4 inches. So clearly you expect to have more distance covered and on actual land. All right, so let's look at another one. So here we have a plan of a room. It's a simple plan. So you have a scale at the lower right corner. You see the scale is 1 to 50. Now, as you can see, there's no unit applied here on the scale. However, there are units reflected on the diagram. What does that mean? So for every centimeter on the diagram, it actually represents 50 centimeters in real life. So let us look what I'm going to ask today. So 1 to 50 units are the same. Whatever unit you measure on the diagram, it's the unit that you'll use in actuality. All right, for every 1 centimeter, I just said that. Let's move on. What is the longest side of the room in actuality? So on the diagram, the longest side clearly is 9 centimeters. How do I figure out how many centimeters it is in my actual house? All right, so let's look at the ratios that exist. So we have 1 to 50, right? That's the first ratio. Then we know that we have 9 centimeters, and I would apply the same concept. To get from 1 to 9, I multiplied by 9. Therefore, 50 multiplied by 9 will give me 450. So when I have 9 centimeters on my plan, it represents 450 centimeters in real life. Now, what is some information you need to know here? What about centimeters and meters that you know? Let's look at it. So we know that 100 centimeters will equal 1 meter. Excellent. So if I have 450, that means I have 4.5 meters or 4.5 meters. All right, so 9 centimeters will give me 4.5 meters. All right, another question with the same plan. You need a doorway to be 1 meter wide. How many centimeters would represent it on the plan? So you know in actuality, your doorway is 1 meter, which I just gave you some bit of information. 1 meter is the same as 100 centimeters. And you can pretty much work it out in your head. So if 50 centimeter is to 1 centimeter on the map, yes, man. Let's see if you got it right. So 1 meter is equivalent to 100 centimeters. Therefore, the ratio exists is 1 to 50, 1 to 50 centimeter here on this particular drawing. So if you want to represent 100, what do you do? All right, so you would have multiplied 50 by 2 to get it to 100. You will also multiply the 1 by 2. So 2 centimeters will give you the measure of 100 centimeter in actuality. So on your diagram, your doorway must be 2 centimeters. All right, awesome. So you know what time of the day it is. It is time for your CT and GILS exam questions. Let's pretty much go through these. Okay, on a diagram, 2 centimeter represents 10 meters. So what's the ratio? 2 centimeters to 10 meters. All right, a line is drawn 8 centimeter. What does this line represent? So let us look. So we look at our existing ratio, 2 centimeter to 10 meters. And we have, so now we know 8 must be mapped on to what? We don't know yet. Let's figure out how we're going to do. So we look at the relation with 2 and the 8. The 2 and the 8, to get from 2 to 8, you'd multiply by 4. You must apply it also to the other part of the ratios. So 10 multiplied by 4 will give us 40. So for 8 centimeters, you get 40 meters. And your option would be option C. All right, great job, guys. Let's look at the next question. On a map, 1 centimeter represents 2 kilometers. What is a distance represented by 6 centimeters? All right, so what is the ratio? 1 centimeter to 2 kilometers. All right, so let's look. So we know that the next ratio will have 6 centimeter, and we're trying to figure out how much kilometers, how many kilometers. What do? We look at the relation to the ones that exist. From 1 to 6, you multiply by 6, apply it also to the other part of the ratio. 6 times 2 gives us 12. So there we go, option A. And our last question of the afternoon, you're making eggs, you're making omelets. If you require 3 eggs to make an omelet and you want to make 6 omelets, what do? So we equate again, we find 2 ratios. So to get from 1 to 6, we would multiply. So 6 times 1 is 6, 6 times 3 is 18. So if you're doing 3 omelets, that would be 18 eggs. Awesome job, guys. Option D. Thank you so very much.